All right. I forgot to put up my applause today. So there we go. Okay. So I think probably we'll be a little bit excited because we're not doing quadratic formula anymore this week, which is nice. We are, however, still solving quadratic functions, but this, my friends, is review. This is the last thing that we did before we left. Well, actually, that's not even true. We're backing way up and doing a review of like how to factor. And then later on, we'll be solving by factoring. So this was from chapter 8. And then we'll get into, factoring and solving a little bit later. Let's just review actually how to factor. So factoring trinomials, remember that means 3 terms when a equals 1. So standard form of quadratic function, y equals ax squared plus bx plus c. For factoring, just factoring, not solving, we don't care about that. Okay, so just ax plus squared plus bx plus c. Now, when a equals 1, which it does, if you have just x squared plus bx plus c, and it's plus or minus bx plus or minus c, kind of depending on what your signs are. Then you look for 2 numbers that multiply to c and that add to b. Hopefully that's ringing a bell. So your answer would be the product of 2 binomials. So it'll look like x plus a number or minus a number, and then x plus or minus a number. So when you find those 2 numbers that multiply to c and add to b, those are written as your second term. So that's your number and your number, okay? So it'll always be x plus or minus, and then x plus or minus, and then whatever 2 numbers you find. All right. So super easy. X squared plus 7x plus 10. What is c? Remember, it's a x squared, bx, and c. So c is 10. What is b? That's 7. Pairs of numbers that multiply to c. Well, how do we get to 10? We have 1 times 10, or we have 2 times 5. Which of those pairs also add to b? Well, 1 times 10, if you had 1 plus 10, would be 11. 2 plus 5 is 7. So that would be 2 and 5. And you use 2 and 5 to write your 2 binomials to have it look like this. So this will be x plus 2 times x plus 5. And I know some of you are asking, does that matter if I have x plus 5 times x plus 2? No, it does not matter. Those are the same thing. So no worries. All right. Now, x squared plus 2x minus 15. What is c? So ax squared plus bx plus c plus or minus c. C, remember, you got to take the sign with it too, is negative 15. What is b? That would be 2. What are some pairs of numbers that multiply to c? Well, that multiply just to 15 is 1 times 15 or 3 times 5. But to multiply to negative 15, remember, one of these is going to have to be negative. So now it's either negative 1 times 15 or 1 times negative 15 or negative 3 times negative 5 or negative 3 times 5. And if you will recall, you will know which one is negative because of this sign. Remember, if you're adding to b and you're adding to a positive b, my larger factor must be positive here. Because remember, the larger factor wins the sign battle. So if you have a negative number that's smaller than a positive number, your answer is going to be positive. If you have a negative number that's bigger than a positive number, your answer is going to be negative. So if I look at negative 1 and 15, well, first of all, larger factor must be positive, so I can take that out. So it's either 1 times negative 15, or if I look at 3 and negative 5, 5 is the larger one. 3 is not, so that's out too. So it's one of those 2. Well, 1 plus negative 15 would give me negative 14. Oh my gosh, and I just totally forgot that it wasn't negative. I am so very sorry. So it'll either be, negative 1 times 15 or negative 3 times positive 5. Because again, as I just said and then forgot, is that the larger number must be positive. So in this instance, it's either the 15 or the 5, right? So if I have negative 1 times 15, that's going to be positive 14. That's not 2. If I have negative 3 and 5, negative 3 plus 5 is, in fact, 2. So it's negative 3 and 5. And so you use those to write your binomials. So you have x minus 3 times x plus 5, again, or x plus 5 times x minus 3. Remember, you can always check your numbers too, or check your answers by like re-multiplying them out. So if I wanted to see, well, do I have this right? I could do x times x, which is x squared, x times 5, which is plus 5x, negative 3 times x, which is minus 3x, minus 3 times 5, which is minus 15. And then I combine my like terms in the middle, x squared plus 2x minus 15. That is what I had in the beginning, so I am correct. All right. So like, believe it or not, that's it. That's the only thing for today in terms of notes. But this not foolish factoring, just ABAC factoring is your optional assignment for today. And I would do this. I don't remember what the answer is to it, but I will find that and post it. So by the time you actually get to this, it'll be posted up there with the answer. So like number 1, again, you're looking for what multiplies negative 18, adds to negative 3. So what multiplies to negative 18 and adds to negative 3, your larger factor is going to be negative. So multiplies 18 is 1 and 18, 2 and 9, 3 and 6. Larger factor is negative. So it's a negative 18, a negative 9, or a negative 6. If I did 1 plus negative 18, that would give me negative 17. That's not going to work. If I did 2 plus negative 9, that gives me negative 7. Not going to work. 3 plus negative 6, that gives me negative 3. That one works. So it's x plus 3 times x minus 6. And I go down here and I look and I don't have, let's see, I don't have a x plus 3 and x minus 6, but I have x minus 6 and x plus 3. So remember, those can be, the order of those can be switched around, and that's fine. So m, that's what 1 is going to be. So everywhere I see a 1 in here, which is just one spot, I think, then I'm going to put m. Okay. Remember now, 2, 10, and I think that's it. These are what was called difference of squares, right? So like if the first term was a perfect square and the last term was a perfect square and there was no x term, then it was just the square root of this one, which is x and x, the square root of this one, which is 3 and 3, 1 is plus, 1 is minus. So x plus 3 times x minus 3. I'm looking at the bottom here, sorry. I cannot find it, probably because I'm looking too fast. There we go, it's h. So I should cross that out too. So that's h for 2. H. Okay, and then number 10 here, same concept. X squared is a perfect square, 25 is a perfect square. So square root of x squared is x and x. Square root of 25, 5 and 5. 1's plus, 1's minus. And then plus 5 and minus 5 is e. So anywhere I see a 10, I would put an e. And all the rest, you can do like that. I will say also though, like number 8, let's take a look at that one. So if we have things that multiply to 25 and add to 10, the only things that multiply to 25, and they're both positive, so they're all factors are going to be positive here. So 1 and 25 are 5 times 5. Well, 1 plus 25 would give me 26. 5 plus 5 would give me 10. So that's when it's going to work. So it's x plus 5 times x plus 5. But if you look down here, you're not going to find that. What you do see is, where is it? C here says x plus 5 squared. Remember, anything times itself is that squared. So this I can rewrite as x plus 5 squared. So if you don't find answers like that, like they're not going to show up as x plus 5 times x plus 5. They'll show up as x plus 5 squared. So that is C, and that's 8. All right, sound good? So yeah, so again, do as many of these as you either want to or feel that you need to, just to kind of recall, you know, how to do them. All right, that is it for today. Short lesson. Have a good one.